And welcome back, friends, to Cajun Coding. This is St. Raz, and we are continuing on our path to learn Python 3 using the Memu emulator and the Solo Learn application, both of those available for free. Last time we did a little work with Boolean logic, and now we're continuing on with operator precedence. And it says operator precedence is a very important concept in programming. It is an extension of the mathematical idea of order of operations, multiplication being performed before addition, etc., to include other operators such as those in Boolean logic. The code below shows that equal to has a higher precedence than or. So if we have here false is equal to false or true, the way that is read is false is equal to false, which is false, or true. Now the or means that if either one is true, then the entire expression is true. So false is equal to false, that's true or true, so that's going to be true. Now if we do it this way, if we use the parentheses to specify that we do this first, what we're going to do here is false or true. Well, false or true, if either of those is true, then the whole thing is true. So it's true. So it would be false is equal to true. Well, false is not equal to true, so that would resolve to false. So see, we have the same Boolean expressions or same Boolean values in the same order with the same comparator symbols, same comparison symbols. But here we're using enclosures to change the order of operations, and that demonstrates why this is so important. The last one, of course, here also evaluates to true. These parentheses here are redundant because without any parentheses, these are going to be compared first anyway because of the order of precedence. That doesn't mean putting these parentheses here is bad. It's actually good because that, even if it doesn't change the order of operation, it can make it more clear. Much of the code that you're writing is going to be not just for the interpreter to execute. The way you write it is also going to be for human eyes that are looking at the code, and it's best to make whatever you're trying to accomplish clear for anyone who's going to be reading that code, including your future self, because every programmer has had the experience of looking at some twisted mess of code that's like spaghetti and wondering what idiot wrote it, and then it starts to look familiar and they realize I am the man. So, or a woman. Girls make messy, hard to maintain spaghetti code too before they're experienced programmers. So let's be inclusive there, and let's try to keep the code pretty clear to read. Python's order of operations is the same as that of normal mathematics: parentheses first, then exponentiation, then multiplication, division, and then addition, subtraction. What is the result of this code? If 1 plus 1 times 3 equals 6, print yes, else print no. So, the question is 1 plus 1 times 3 equal to 6? Multiplication first, 1 times 3 is 3, and then 3 plus 1 is 4, not 6. So it would be no. Why 6 here? Because 1 plus 1 is 2. 2 times 3 is 6. But that's not the correct order of operations. So, no. And here's a nifty table here. Following table lists all of Python's operators from highest precedence to the lowest. Exponentiation first. This is complement, unary, plus and minus. Method names, the last two are plus, at, and minus, at. Multiply, divide, modulo, floor division, addition, subtraction. right and left bitwise shift. I wonder if we're going to do bitwise operators maybe later on. I'm familiar with the concept in other languages. I'm not sure exactly how Python handles it. It is an interesting topic. This is a bitwise and, bitwise exclusive or, bitwise or, comparison operators, equality operators, membership and identity operators, Boolean not, Boolean and, Boolean or, and then lastly assignment operators. You notice assignment operators at the very bottom, and that's interesting. That's for a very good reason. If you need to assign a new value to a variable, but you don't know what value you need to assign, you need to perform some computations or comparisons first, then by having the assignment operator by default as the lowest in the order of precedence, it allows you to put X assignment operator and then perform those comparisons, conditionals, or arithmetic operations all in a block of code to the right of the assignment operator. And then when it's done doing all that boring mathy stuff that we invented computers to do, then we'll make that assignment to the variable. So operators in the same box have the same precedence. So you'll see all of it, like this whole box, they have the same precedence. Precedence being equal, I haven't seen it specifically stated in our Python course here, but in most languages, symbols that have the same order of precedence are going to be executed from right to left. What is the result of this code? We're going to assign to X 4, assign to Y 2, both integers. If, let's see, not 1 plus 1 equal to Y or X equal to 4 and 7 equal to 8. Oh my goodness, this is a mess. Okay, so let me see. I think the OR would be executed before the AND because those are equal in the order of precedence. The arithmetic operations are going to take place first though. So if 2 is equal to Y, 2 is equal to Y, or X equal to 4, both of those are true, and 7 is equal to 8. So if we take this whole thing from here to here, because of the AND, if anything is false, the whole thing is false. Okay? 7 is not equal to 8. So the whole thing is false from here to here. So it's false, not flips the value to true. So if this whole thing is true, then we print yes. Let's see if I'm right, because I might have missed something in there. Oh, I'm wrong. What happened? Okay. So, else if X is greater than 4 is greater than 2, so print no. I'm not sure what I messed up there though. Let me see. No. So that's correct. See 1 plus is 2. That's true. I think the AND was executed first, so that would be false. Yeah, except this is true. Oh, okay, so if we compare these two, and X equal to 4, 7 equal to 8, that's false. So from here to here would be false. But this is true. So this whole thing resolves to true, and the not would reverse the value to false. So this would be false. So then it would go down to elif. In elif, this statement is true, so it prints no. So it resolves the AND first and then the OR. But then it does each of these expressions first. I think that's why it got the result that it did. Okay, while loops. An if statement is run once if its condition evaluates to true, and never if it evaluates to false. A while statement is similar, except that it can be run more than once. The statements inside it are repeatedly executed as long as the condition holds true. Once it evaluates to false, the next section of code is executed. Below is a while loop containing a variable that counts up from 1 to 5, at which point the loop terminates. Here we've got I equals to 1, and I'm going to get to, there's a reason they used I here, but I'll get to that in a moment. While I is less than or equal to 5, and then we have a colon, be sure to indent this, print I, then I equals I plus 1. Then print finished, and this is not indented the way this is. It's aligned with the while keyword here. And the result, 1, 2, 3, 4, 5, finished. And what's happening here, while I is less than or equal to 5, well, 1 is less than or equal to 5. So we're going to print I, 1, and then I is going to be equal to 1 plus 1, which is 2. And we go back up here, I is less than or equal to 5, 2 is less than or equal to 5, so we're going to print 2, and then we're going to add 1, make it 3, while 3 is less than or equal to 5, and it's going to continue looping. When I is 4, we're going to add 1 to it, and it's going to be 5. While I is less than or equal to 5, 5 is equal to 5, so it prints 5, and then we add 1. While 6 is less than or equal to 5, 6 is not less than or equal to 5, so this code is not executed, and we go down to print finished. The code in the body of a while loop is executed repeatedly. This is called iteration, and that's why they use the variable name I. It's not a rule logically, and it's not I don't think it's something most people would be angry about, but they'd probably look at you a little sideways if you didn't use I as the name of your iterator. When you see I in code, it's usually an iterator, and that's just that's kind of to make it easier to read. Now, in those instances where you might have a loop inside a loop, it's common for programmers to use J as the iterator. It's just the letter right after J. If you have a loop within a loop within a loop, you might want to examine your life choices. If you usually don't want to have a loop contained inside a loop contained inside another loop. We may get to discussing that later, but if you've got a loop inside a loop inside a loop, that is probably going to be using a lot of processing overhead. It's not going to be very fast, and you should look for a better way to do things more efficiently there. But we're not going to get too deep into the weeds with that particular issue. But I is a variable name often used for an iterator, whether that's a while loop or a for loop, which I'm sure we'll get to soon. How many numbers does this code print? I equals 3. While I is greater than or equal to 0, which it is if it's 3, we print I, so that's 3. Then I equals I minus 1, so we're going down, we're decrementing. So it's going to be 3, and then it's going to be 2, and it's going to be 1, and then it's going to be 0, while I is greater than or equal to 0. So it will print it at 0. When it gets to -1, it's going to kick out of the loop. It's not going to print -1. So what it's going to do is it's going to print 3, 2, 1, and 0. Now it says how many numbers does the code print. It's actually going to be 4 characters. So I think the answer they're looking for is 4, not 3, 2, 1, 0. While loops. The infinite loop is a special kind of while loop. It never stops running. Its condition is always the condition always remains true. An example of an infinite loop: while 1 equals 1, print in the loop. And this program would indefinitely print in the loop. Indefinitely doesn't mean forever. Indefinitely means for an undetermined period of time. It might mean it would infinitely print in the loop. Of course, the physical universe and the limitations of technology and time would mean that it's not really infinite, but it would be until computer breaks down, memory overflows, or someone realizes something went wrong and stops the program. But theoretically, it would be infinitely. You can stop the program's execution in Python by using the Control-C shortcut or by closing the program. Fill in the blanks to create a loop that increments by the value of x. Increments the value of x by 2 and prints the even values. So we've got x equals 0. So while x is less than or equal to 20, we could put the colon there. I don't actually recall, but I think it's a colon, isn't it? Okay, so we're going to print x, and then x plus equals 2. It's going to add 2 to that. So that should do it. Okay. It looks like the conditionals are all followed by a colon, so bear that in mind. It's important to understand the logic. Syntax, I think of the two, logic is more important. And if you make a mistake with syntax, you can kind of Google that or look something up, look at some other portion of the code or something like that. Obviously, syntax is important and you shouldn't have to be looking up stuff all the time. But the logic and the underlying programming concepts are more important if you had to pick one of the two. Break. To end a while loop prematurely, the break statement can be used. When encountered inside a loop, the break statement causes the loop to finish immediately. So what we've got here, while 1 equals 1, and then we have a code block here. Okay, 1's always equal to 1. So this code block, this while loop, is going to run forever or until something stops it. Someone closes the program out, uses Control-C, the computer runs out of memory, whatever. Something's got to stop it. The break keyword allows us to establish a condition that will stop a loop that isn't finished. This loop never finishes, but it can be stopped by a break condition. And what we've got inside that loop, we've got an if conditional. If I is greater than or equal to 5, then we're going to print breaking, and then we have just the keyword break. Break is going to break us out of the loop that the break is contained within. Now the if block doesn't count as a loop, so it's not going to break out of that and put it back in the while loop. So it's going to break out of the while loop. Immediately after the while loop, as you can see by the indentation here, print is a line, so it's going to print breaking, breaks out of the loop, and it's going to print finished. So, but before that, of course, it's doing this printing up here. So it's going to print 0, 1, 2, 3, 4. When it's equal to 5, it's going to break out of the loop, print breaking, actually print breaking, then break out of the loop, and it prints finished, which is the command after the while loop. Using the break statement outside of a loop causes an error. Of course, you can have nested loops, so you may have a different break statement inside each loop, but if you call break, or if you use break, and it's not inside any loop, then you'll have an error. How many numbers does this code print? I equals 5. While true, print I equals I minus 2. If I is less than or equal to 2, break. Now you notice this while loop is kind of weird. It just says while true. Okay, that's perfectly valid statement. It's not something you would likely use in an actual program created for something useful, but we're just setting this while loop up to be infinite so we can practice using the break. So print I, that's 5. I equals to I minus 1, so we're going to reduce it by 1. So now I is 4. If I is less than or equal to 2, then we're going to break. It's not yet, so it's going to be 5, 4, 3. Then I is going to equal to 2, and we're going to break out. So it's going to be 5, 4, 3. It's not going to print 2. You know what? I'm sorry. It is going to print 2 because the print is up here. So it's going to be 5, 4, 3, 2. Then the 2 is going to be true here and do break. So 5, 4, 3, 2. That's going to be 4 numbers. Hey, what happened? Okay, 5. So say while true, 5. See 5, 4, 3. Oh, you know what? Actually, we've got the print here, so it's going to be 5, 4, 3. Then we reduce it to 2. Then it checks for equality to 2 before going back to the top. So it's going to print 5, 4, 3. It prints 3. It reduces it to 2. It checks if it's equal to 2 here, and it breaks. So it's actually only going to be 3 numbers. And you have to be careful about where it's printing, where it's changing the variable value, and where it's checking for a value before breaking or not breaking, as the case may be. So another statement that can be used within loops is continue. Unlike break, continue jumps back to the top of the loop rather than stopping it. So while true, which is setting us up for an infinite loop, I is equal to I plus 1. If I equal to 2, print skipping 2, continue, which would bring us back up here. If I is equal to 5, print breaking, and then break, then print I, and print finished. So what it's going to do is we're going to start out, let me see, I equal to 0. So while true, what we're doing is incrementing I here, and we do that at the top of the loop every time. So it starts out as 0, but since the first thing we do is increment it, it never prints 0. So it doesn't print that. It prints 1, and then it prints skipping 2 the next iteration through the loop. It prints skipping 2, and then does 3, then does 4. When it reaches 5, the break statement is executed. We do have a print before it actually breaks. We check it's 5, we print breaking, then we break it. So breaking is printed. Then it breaks out of the loop and prints finished. Basically, the continue statement stops the current iteration and continues with the next one, which is skipping is one of the most common uses for the continue statement. We're not breaking out of the loop. We want to keep running it, but we don't need to do anything else in the block of code within that loop for that particular iteration. So we just go back to the top of the loop. And continue assumes that we're using it within the context of a loop. So if you use it and it's not contained in any loop, then it would cause an error. Which statement ends the current iteration and continues with the next one? Well, let's continue. It probably should say resumes, because when they use continues, that's kind of a giveaway, but they didn't ask me. Let's see, and we've got lists. Lists are another type of object in Python. They're used to store an indexed list of items. A list is created using square brackets with commas separating items. The certain item in the list can be accessed using its index in square brackets. For example, words equals hello and hello world and exclamation point or bang. And each of those elements is contained within double quotes there, and they're separated by commas. Print words 0 contained in the square brackets. Print words 1 and print words 2, that would be hello world exclamation point. Now these are on separate lines, which is why we have each of those items on a separate line there. The first item the first item's index is 0 rather than 1, as might be expected. I'm not sure whether they're saying you would expect it to be 0 or you would expect it to be 1. Someone new to programming would expect the first item to be 1. Someone who's studied programming already probably expects the first item to be indexed 0, because 0 indexed entities are a very common thing in the world of computer programming. And I say entities because all kinds of things could be 0 indexed. If you're looking for a particular spot in a string, if you're looking for a particular list item, if you're looking for something in an array. And what they're describing as lists here, this is what would be called an array in other languages. I want you to remember this as a list, because there might be another thing in Python they call arrays. Maybe they're using the word array for something else. I don't know yet. So these are lists, but if someone's talking about Java and they say something about an array, or JavaScript and they mention an array, imagine this, because this is what they're talking about. But we're going to call these lists. What is the result of this code? Nums equals 54321. Print nums 1. So we're going to start counting from left to right. And the first one we're going to start counting from 0. So 0, and this is index 1, and the thing in index 1 is the integer 4. Now if these were enclosed in double quotes, it would still be 54321, but these would be the numerals, the string consisting of one numeral, rather than the integer of value 5432 or 1. So an empty list is created with an empty pair of square brackets. So here empty list equals 1. This is 0. Empty list equals just the brackets, not 1. This isn't 0. This is a list containing no items. 0 is actually an integer. So you could put a 0 in that. It would have one item, and that item would be the integer 0. But this has no items in it. The result, the result of printing is that it displays the brackets, but there's nothing inside it. Most of the time a comma won't follow the last item in a list. It's perfectly valid to place one there, and is encouraged in some cases. Not sure why you would encourage that, but I'm going to take their word on it. How many items are in this list? And of course they've got a comma after the only item in there. There's only one item. If you want to print that item, you would use index 0, but the number of items is just 1. And then the comma there, they said you can place a comma behind the last item. The comma isn't an item. The comma is just a delimiter to separate one item in the array, in the list from the next. And there's nothing behind it, so there's nothing there. So one item. Typically a list will contain items of a single item type, but it is also possible to include several different types. Lists can also be nested within other lists. So number is equal to integer 3. Things is a list consisting of, the first item is a string called string. The second item, which is index 1, is the integer 0. The third item is another list, and that list consists of 3 items, 2 integers, and number. Number's a variable, so this is a variable name, and the variable itself contains the integer 3, which is not the same thing as containing the integer. It's not the same thing as this list containing the integer 3, because if the number changes, if the value in number changes, then it would change here too. And then the 4th item is a float 4.56. Print things 1, 0. Print things 2, the list of these items. And print things 2, 2. Now we've got two things here. So what we're going to do is print things at the index 2. This is index 0, 1. This is index 2. It's another list. What's at index 2 in that list? It's 0, 1, 2. So we just print 3. As you can see, 0, the entire list, and then just the item from the list indices requested, which would be index 2 from the outside list, and then index 2 from the list at index 1. Excuse me, at index 2. So item 2 from the object at item at index 2 from the item at index 2. Lists of lists are often used to represent 2D grids, as Python lacks the multidimensional arrays that would be used for this in other languages. Some languages support multidimensional arrays, which are arrays of arrays, effectively. Others don't actually support multidimensional arrays natively, but you can emulate that by making arrays of arrays. So kind of 6 of one, half a dozen of the other. There are some technical reasons there's a difference, but that's a bit beyond what we're studying here. Fill in the blanks to create a list and print its 3rd element. So lists, we got 3 items here. We got the closed bracket. We don't have the opening bracket, so we'll put the opening bracket in there. And then print list, print its 3rd element. The 3rd element is going to be index 2. And there we go. Indexing out of the bounds of possible list values causes an index error, and I can almost guarantee you it's something you're going to be seeing a lot of due to miscounting something, or an incrementer getting too high or being set too low or something like that. Some types, such as strings, can be indexed like lists. Indexing strings behaves as though you are indexing a list containing each character in the string. For other types, such as integers, indexing them isn't possible, and it causes a type error. So, string hello world, print str. Actually, this shouldn't say string. It's str is the name of the variable containing the string hello world. So print str index 6. So we've got 0, 1, 2, 3, 4. The space counts, that's 5. And then 6 would be the lowercase w. And when we print that, we get a lowercase w. Which line of code will cause an error? So we've got num 54321, and then the item in index 3. So 0, 1, 2. In index 3, the item there is not the integer 2. The item is a list containing one indexed value, which is 2. So if we print num 0, we get 5. If we print num 3, 0, we get 2. Print num 5. Well, we've got obviously 5 items here, but num index 5 doesn't actually exist. So we've got index 0, 1, 2, 3. The fifth item is index 4, so the index 5 would indicate the sixth item. There is no sixth item, so that is going to produce an error. Which line is that? Oh, I'm sorry. So 1, 2, 3, 4. So it'd be line 4. I was counting this as a line. That's not part of the program. Okay, and list operations. Any minute now. Sure, we're going to have an ad after that. Wait. The item at a certain index in a list can be reassigned. For example, nums, which consist of 5 items, they all happen to be 7s. Instead of printing, we're going to put nums index 2, and then we're going to use the assignment operator, and that's going to put the value here into that index. And then when we print nums, the item in index 2 is going to be changed. So it would be 77577, like so. And we often use lists to contain values that may change, and so we use that particular syntax to change items in the list. What is the result of this code? Nums equals 1, 2, 3, 4, 5. Those are obviously integers, those 5 items. Nums 3 equals nums 1. Okay, so what we're doing here is we're using the assignment operator to change the value of the item in index 3, but we're going to call nums index 1 to get that value. So nums 3 is right here. So it's 0, 1, 2. This is 3, index 3. And we're going to pull that value from nums index 1. This is 0, so it's 1. So it's going to be 1, 2, 3, 2, 5. But we're only going to call nums 3. So that would be 2. Unless I got lost somewhere. Yeah, there we go. List operations. Lists can be added and multiplied in the same way as strings. So nums 1, 2, 3, print nums plus 4, 5, 6, and then print nums times 3. So what we're going to have is it's going to print nums, which is this list, plus it's going to print 4, 5, 6. So it'll be 1, 2, 3, 4, 5, 6, like that. Or we can do print nums times 3. Now we didn't change nums here, we just printed it. So nums is still going to be just 1, 2, 3. And we're going to print that 3 times. So 1, 2, 3, 1, 2, 3, 1, 2, 3. Lists and strings are similar in many ways. Strings can be thought of as lists of characters that can't be changed. Fill in the blanks to create a list, reassign its second element, and print the whole list. So we've got nums. So we're creating this list. We're forgetting here we didn't close the bracket there. Let's see, nums, reassign its second element. Well, the second element is going to be index 3 because it was 0 indexed, remember. And then print the whole list. The name of the list is nums. What did I do? Oh, we didn't reassign the second element. Yeah, I did. Oh, you know what? The second element is 1. I'm backwards. The second element is 1. And we need to close the bracket and then nums. To check if an item is in a list, the in operator can be used. It returns true if the item occurs 1 or more times in the list, and false if it doesn't. So we've got a list of strings consisting of the words spam, egg, spam, sausage. Print spam in words. Now it's not going to print spam, it's only going to print the answer to our question. Is the string spam in the list named words? Well, it is, so it returns true. Print egg in words, it is, so it prints true. Print tomato in words, there's no tomato in this list, so it returns false. The AND operator is also used to determine whether or not a string is a substring of another string. And we'll probably get to that a little bit later there. What is the result of this code? Nums, integers, 10, 9, 8, 7, 6, 5. Nums 0, we're going to assign to nums 0, which is currently 10. Nums 1 minus 5. And what this is doing is going to take nums 1, which is 9. That's an integer, and then we're going to perform an operation on that, subtracting 5. So 9 minus 5 is 4, and we're going to assign the value of integer 4 to index 0. So it's going to be 4, 9, 8, 7, 6, 5. If 4 in nums, it wasn't before but it is now, then we're going to print nums 3. Now this is true, so we're going to print nums 3, 0, 1, 2, 3, which is 7. So it's going to print 7. Otherwise, it would have printed nums 4, which is 0, 1, 2, 3, 4. But since this resolved to true, that else statement is actually not going to execute. To check if an item is not in a list, you can use the not operator in one of the following ways. So we've got nums 1, 2, 3, print not 4 in nums. What you want to do is we're going to be flipping the logic here. So go ahead and resolve this statement first, okay? 4 in nums. Is it? No, it's not. So it's false. Not is going to reverse the Boolean value, so it's going to actually print true, as it does here. Print 4 not in nums. Actually, they're doing the same. They're doing the same thing, except we're reversing the order here, and I kind of don't like that. It kind of grates on me, but it's pretty obvious what they're asking for. 4 not in nums. Well, 4 is not in nums, so again, it's true. Print not 3 in nums. Okay, 3 in nums is true. It's there, and now to reverse the value, it would be false there, and then reversing the order here, which is sometimes they use a fancy word, transposition. So if you transpose those two, it still operates just fine there. So, and fill in the blanks. To print yes if the list contains Z. So what we've got here, the list is named letters, it's got A, B, Z, it does contain Z. So if we use an if conditional Z and we use the keyword in letters, don't forget that colon, the indentation here, print yes. Okay, and the next section is going to be list functions. We're about 45 minutes in. Lessons are usually 45 minutes long, so we're just going to kind of stay with that. And we'll go ahead and pick up there next time. Thanks again so much, everybody, for tuning in. I appreciate it, as always. Like, subscribe, recommend the channel. Any questions, comments, critiques, or requests are welcome always. Thanks again, guys. I'll see you all next time. Bye-bye.